On August 21st, 1961, a commercial airliner climbed higher than any passenger jet had ever flown, leveled off in air so thin the sky had turned black, and then did something no airline would ever knowingly ask of a paying customer. It pointed its nose at the ground and dove toward the speed of sound. Not by accident, not in an emergency, on purpose. The aircraft wasn't a fighter. It wasn't a research rocket plane bristling with instruments and painted government orange. It was a Douglas DC-8, dressed in the red and white livery of Canadian Pacific Airlines, already carrying the name it would fly under for paying passengers a few months later, Empress of Montreal. Inside were four men who had every reason to believe this flight could kill them, and one very specific reason to do it anyway. To understand why, start with what actually sold an airliner in 1961. Not speed, not comfort. The signature on the purchase order was a bet that this particular machine would come back from anything the sky ever did to it. By the late 1950s, the jet engine had already reshaped commercial aviation once. Boeing's 707 had flown first in December 1957, and it spent every month since eating into a lead Douglas assumed belonged to it by birthright. Douglas had built the DC-3, the aircraft that arguably invented mass air travel, and it was counting on that legacy alone to carry the DC-8 into first place. It didn't. The DC-8 flew 6 months behind the 707, and in an industry where a single airline order was worth the value of a small company, 6 months was long enough to lose a decade. What Douglas needed wasn't a way to fly faster than Boeing. It was a way to answer a question no salesman could talk his way around. What happens if this thing, at cruise altitude, ever gets away from the pilot? Nobody signing a $100 million purchase order in 1961 was buying speed. They were buying an answer to that question. The company didn't need a faster airplane. It needed the world to stop being afraid of a fast one. And something going wrong at jet altitude had a very specific shape. Every jet airliner flew with a number stenciled quietly in its flight manual, a maximum operating speed it was never supposed to exceed. Past that number, the physics changed. Air moving over the wings could stop following the surface smoothly. It could separate, form shock waves, buffet the airframe, or even push back against a control input instead of obeying it. Engineers had a name for one version of it, Mach tuck, a jet nosing itself downward on its own, exactly when a pilot needed it to climb. Fighter pilots had already found pieces of that edge, occasionally at the cost of the airplane. No commercial airliner had ever been deliberately flown there to find out what the rest of the answer looked like. Douglas's test pilot, William Magruder, proposed something nobody expected. Instead of waiting for an accident to reveal what happened past that limit, prove it themselves, on Douglas's own terms, in daylight, with cameras running. Magruder was not a marketing man playing pilot. 3 years earlier, he had sat in the co-pilot seat for the DC-8's very first flight. He knew this airframe's history before this particular airplane had one of its own. A former Air Force test pilot and engineer, he had flown machines ranging from fighters to the B-52 bomber, and had flown alongside Chuck Yeager, the first person ever to break the sound barrier in level flight. He understood exactly what he was proposing. Put an ordinary airliner into a dive steep enough, at an altitude high enough, to cross Mach 1 and pull it back out again, intact, in front of witnesses. If it worked, Douglas could tell every airline in the world, this aircraft has already survived worse than anything you'll ever ask it to do. If it didn't, there would be no press release. There would be wreckage. The plan itself was almost absurdly delicate. The DC-8 cruised comfortably at Mach 0.82. Its tested limit, the fastest speed Douglas had actually flown it across nearly 4 years of flight testing, was Mach 0.95. Everything past that number was uncharted for this specific airframe, and Douglas's own engineers knew it. Pulling out of a dive with elevators fighting a shockwave at over Mach 1 wasn't a formality anyone inside the company pretended it was. It was a calculated risk with no guaranteed second attempt. If you're enjoying this documentary, consider subscribing. Every video here is carefully researched to bring you the real stories, remarkable aircraft, and pivotal moments that shaped aviation history. Now, let's continue. What made the plan possible wasn't bravery. It was a detail most people never think about. The speed of sound isn't fixed. It bends with temperature and altitude, so the colder, thinner air 7 miles up meant Mach 1 could be reached at a slower true airspeed than at sea level, a gentler way, in aerodynamic terms, to punch through the sound barrier. Douglas's engineering team, working under aerodynamicist Roger Schauffele, built a precise set of charts. At exactly this altitude, at exactly this dive angle, the airplane would cross the sound barrier as softly as physics allowed. It was a plan built on one idea: control every variable that could be controlled, and hope the one variable that couldn't be tested in advance would take care of itself. Then, the night before the flight, something happened that had nothing to do with aerodynamics and everything to do with how imperfect real aviation history actually is. Someone at the Long Beach plant accidentally damaged the wing's leading edge slats. During the pre-flight inspection the next morning, flight test engineer Richard Edwards accidentally damaged the trailing edge flaps as well, catching one on equipment left beneath the wing. Both systems, used to keep the airplane controllable at low speed during takeoff and landing, were now unusable. On the record flight of Douglas's career, on the aircraft chosen to prove the DC-8's toughness to the entire industry, the airplane could no longer configure itself for a safe takeoff if it lost an engine. Magruder's response, according to Edwards, was simple. They would take off anyway, flaps up, and accept the added risk. Nobody scrubbed the mission. Nobody watching from the runway could tell that anything was wrong at all. The most closely calculated flight in Douglas's history was about to happen on an airplane that was already flying with something broken before it ever left the ground. They took off from Long Beach and headed roughly 80 miles north toward the Osconia tracking range at Edwards Air Force Base, the same stretch of California desert where Chuck Yeager had broken the sound barrier 14 years earlier in the Bell X-1. Yeager himself joined the flight, flying the F-104 Starfighter chase plane. A second aircraft, an F-100 Super Sabre, carried a photographer to document whatever happened next. The Air Force even supplied a weather balloon to independently verify the atmospheric data the entire dive depended on. Magruder leveled the DC-8 off at just over 50,000 feet, itself an unofficial altitude record for a loaded commercial transport. Edwards, looking out at the sky at that height, later described it simply. He had never seen anything that dark, that close to black, in daylight. From there was nothing left to do but go down. Magruder pushed the nose over into the dive. Edwards' job was to call out airspeed, not Mach number. Mach was too imprecise a target to fly by, and airspeed gave a cleaner number to react to in real time. At a descent rate of roughly 500 feet every second, the airplane was losing 1,000 feet of altitude every 2 seconds. Edwards stopped looking out the window. It looked, he said later, like they were falling straight down. At around Mach 0.96, the airframe began to buffet, a rattling vibration as airflow started to separate unevenly across the wings. Then, just above that speed, the buffet vanished. The airplane had pushed through the roughest part of the transition and was now accelerating into a stretch of air few passenger jets had ever touched. Edwards had mounted small cameras inside the cabin, aimed out the windows hoping to catch footage of the chase planes alongside them. The chase planes never appeared in frame. What the film caught instead was something nobody had specifically planned to document. At roughly Mach 0.97, the DC-8's ailerons, the control surfaces on the wings that let a pilot roll the aircraft, moved upward on both sides at once, moved not by the pilot's hand, but by the shock wave sliding backward off the wing. It was a small, almost silent piece of footage. It was also proof, captured by accident, of exactly the phenomenon the flight existed to investigate. At these speeds, the airplane could start moving on its own. At 41,088 feet, the DC-8 crossed Mach 0.102, a true airspeed of roughly 660 miles per hour, slower in absolute terms than a fighter jet at sea level, but faster than sound in that thin, cold air. It held supersonic speed for about 16 seconds. For those 16 seconds, an aircraft built to carry families and business travelers across continents was technically flying faster than the men who designed it had ever flown it before. Faster, arguably, than any airliner before or since, apart from two purpose-built supersonic jets that wouldn't exist for another 8 years. And then it was time to come back, and coming back was never the easy half of the plan. Magruder began easing back on the control yoke to pull out of the dive. The airplane barely responded. The elevators, the small hinged surfaces on the tail that a pilot uses to raise or lower the nose, were built for subsonic air. At Mach 1, the shockwave forming around the tail was overpowering them. The controls that were supposed to save the airplane were, for a moment, simply not working. There was a backup. The DC-8's entire horizontal tailplane could rotate as a single unit, a more powerful control than the elevators alone, capable of overcoming conditions the elevators couldn't. Magruder reached for it. It didn't move either. The aerodynamic load pressing up against the tail at that speed and that nose-up angle was too great for the tailplane's motor to overcome. For a few seconds, the DC-8 was 170,000 pounds of airliner moving faster than sound, with neither of its two pitch controls responding, roughly 7 miles above the California desert. What happened next is the reason this flight is remembered by engineers, not just historians. Instead of continuing to pull back, the instinctive response and the one that wasn't working, Magruder pushed the nose further into the dive. It was the opposite of instinct, the last thing any pilot is trained to do when the ground is coming up fast. It was also correct. Pushing further into the dive reduced the airplane's angle against the airflow, easing the aerodynamic load crushing the tailplane's control motor. The instant that load eased, the motor turned. The tailplane bit into the air. The aircraft, still supersonic, finally answered. For 6 seconds, the only way out of the dive was further into it. They recovered level flight at roughly 35,000 feet, having fallen almost 15 miles across the desert floor below, covering in less than a minute nearly the width of a small city. Nobody on board described panic. Edwards, years later, remembered it more simply. They weren't frightened so much as relieved they'd gotten through it, and pleased that all the preparation had actually worked when it mattered. In one flight, the DC-8 set unofficial records for commercial transport altitude, payload, and speed. Douglas paid each crew member a bonus. The Society of Experimental Test Pilots later gave Magruder its Kincheloe Trophy, one of flight testing's highest honors. Boeing never staged the same demonstration with the 707. Nobody can say for certain why. Public caution, quiet confidence, or simply nothing left to gain by chasing a headline Douglas already owned. Whatever the reason, the DC-8's dive remained for decades the only intentional supersonic flight ever made by a Western jet airliner outside a purpose-built supersonic transport. Magruder didn't stay to enjoy it. Not long after, he left Douglas for Lockheed, a departure Edwards, who'd flown beside him, remembered as one the company hadn't wanted. It's the closest thing to friction the record shows in an otherwise triumphant story. The man who proved the airplane didn't need him to sell it. The airplane didn't need him too. 18 years later, in April 1979, a Boeing 727 TWA Flight 841 found the same edge of the envelope with no warning and no plan at all. A mechanical failure at cruise altitude threw it into an uncontrolled spiral dive. Nobody on that flight chose to go supersonic. The aircraft did it anyway, tumbling nearly 6 miles in just over a minute before the crew regained control with only a few thousand feet to spare. Everyone survived. There's no record connecting the TWA crew's specific actions that day to Douglas's flight test data from 1961. That direct link can't honestly be drawn. What can be said is broader and just as telling. By 1979, the industry's understanding of how a swept-wing jet behaves nearing and crossing Mach 1 rested on real flight data, not just wind tunnel theory, because a handful of crews, Douglas's among them, had already gone looking for that edge on purpose. That is the irony sitting at the center of this story. The Empress of Montreal's dive was billed as theater, a headline, a sales pitch dressed up as a feat of engineering confidence. But the thing it actually produced outlived the marketing purpose it was built for. Somewhere between a slide rule chart and a stopwatch reading of 16 seconds, a stunt became data, and the data outlived everyone who watched it happen. That boundary, the maximum operating speed stenciled in a modern airliner's manual, the reason a pilot today is trained to treat an overspeed warning as an emergency and correct it in seconds, still exists because somebody had to find out what was on the other side of it. In 1961, 4 men flew a passenger jet to the edge of what it could survive, not to see how fast it could go, but to find out what would happen to everyone else's flight years later if a jet like it ever got there by accident. They found the edge. They found the controls could fail there, and with less than 3 miles of falling sky left to work with, they found a way back. Empress of Montreal spent the next 2 decades doing exactly what it was built for. Climbing to cruise, leveling off, carrying people who boarded without a glance at the airframe beneath their seats. None of them ever knew they were flying in the one airliner that had already found the sky's outer edge and returned from it. Somewhere in that thin black air above the desert is still the answer to a question no passenger ever thinks to ask. What happens if we go too fast? In 1961, 4 men went and found out so the rest of us never would have to.